Hello students. So in this class, we will be discussing a problem on isometric projection of a cone. The solves which we have discussed so far, they were having some corners or slant edges so that we can transfer these points. So whereas in the case of a cone or a cylinder, we doesn't have any such parts. Now the question is draw the isometric projection of a cone of base diameter 70 mm and axis 80 mm when it is vertical or when it rests on its base on HP. So that's the question. So the question is on isometric projection. So immediately you have to go for an isometric scale. So as we discussed in the previous sessions, you have to draw a baseline OA, then two lines inclined 30 degrees and 45 degrees. And on the 45-degree line, you mark the dimensions whose isometric length has to be found out. So here the diameter is 70. So we need the radius for drawing the circle. So make it as 35. Drop a vertical on the 30-degree inclined line, and that length will be the length corresponding to isometric length of 35. Similarly, find the iso length of 80. Now with iso 35 as radius, draw a circle. Now as I said earlier, in isometric projection, we have two rules. All horizontal edges should be drawn as lines inclined 30 degrees to the base, and all vertical edges should be drawn vertically. So for that, except square or rectangle, whatever be the other type of solids, we have to inscribe them inside the smallest possible square or rectangle. So this is a circle, so I'm going to inscribe this inside the smallest possible square. So I've drawn a square touching the 4 points and I've named it as 1, 2, 3 and 4. Now let us draw the isometric projection. So first of all, we have to construct the isometric projection of the square 1, 2, 3, 4. For that, I'm going to draw the baseline. Now I'm going to pivot any one of the points. Now this circular base is resting on HP. That means all the sides 1, 2, 2, 3, 3, 4, they are all horizontal. So this consider this as a circular lamina lying on the base or lying on HP. So that means all the sides will be horizontal. So our rule is all horizontal should be drawn as lines inclined 30 degrees. So I'm pivoting at point 2. Then I'm going to draw a line of length 2, 3 at an angle of 30 degrees. Similarly, I'll be drawing another line 2, 1 inclined at 30 degrees of length equal to 2, 1. So in a compass, you can measure this length 2, 3 and cut from 2 to 3. Another line length 2, 1 which will be same as the earlier one and mark the point 1. Now you can move this line 2, 3 from the point 1. You can use a scale and a set square combination, or you can use a roller, and you continue with the construction of the other parts. This 30 degree and you complete this one. Now we are going to construct the isometric projection of the circle inside this rhombus. So as you know, a square is converted to a rhombus. Likewise, a circle will be converted to an ellipse. So the isometric view or projection corresponding to a circle will be an ellipse. Now we have to know how we can construct the ellipse here. So either you can put off these 4 points and join them, but using 4 points the curve won't be smooth. So you have to find out more number of points so that the ellipse will be perfect. So we'll be discussing a construction whereby you can construct a clear ellipse within this rhombus 1, 2, 3 and 4. First of all, we'll find out the center of this rhombus. For that, you draw two diagonals so that they will intersect at the center. So this is meant for drawing the axis. Now I'm going to draw an ellipse using 4 center method. So in that, I'm going to draw two lines from 4 to the midpoint of the opposite sides. So this is an obtuse angle. So from the point 4, you draw a line to the midpoint of 1, 2 as well as the midpoint of 2, 3. Similarly, from the point 2, you draw a line to the midpoint of 1, 4 and another line from 2 to the midpoint of 3, 4. So 1 and 2. Now I'm going to draw lines from 2 to the midpoint of 3, 4 and 1, 4. So we got 4 points. So one of the point is 2 and the point is 4 and another 2 points here, one here and one here. So I'll locate the 4 points which we are going to draw as centers. This is the first point, this is the second point, this is the third point and this is the fourth point. Now with this as center, this length as radius, you draw an arc here. Similarly, with this point as center, and the same radius, you draw another arc. So that will touch these 2 points. Now we need to complete this arc. For that, with 2 as center and this length as radius, you join this. So this will exactly meet the other two curves. Similarly, with 4 as center and this much length as radius, using compass, you draw another arc. So this will touch these two lines. So this will give you a perfect ellipse. So while drawing this, you have to have an idea of the visibility concept. So when you're looking at the solid, the inner part, which will be covering this much area, this part will be invisible. So you can draw them as dotted line. So you can partially draw as dotted curve, and the other area can be left light, whereas the bottom portion can be drawn as dark curve itself. So this is how we are going to construct the ellipse. So I've drawn 4 arcs and this is what I get. So this is a smooth ellipse. So I'll explain again. So the various centers are, so I'll use another color for that. So first, the first center, this has center and this much length as radius. I'm drawing the first curve. Then the second curve, the same radius from here to here. Then to complete this with 2 as center, you take this much distance from 2 as center, you would join this curve, draw this curve. Now similarly with 4 as center, this much length, this radius, you join the other curve. So this will give you a smooth ellipse. Now we'll draw the axis. So as we did in the case of a pyramid, we have located the center. Now we need to locate the apex. So it is given here the axis 80 mm long. So from this center point, we draw a line at a height of 80 mm vertically upwards. Now it's a chain line, so convert as line dot, line dot, line dot. So this line represents the axis and I'm labeling the tip as O. Now we need to draw the two outermost generators. So for that, from the point O, you can draw a line so that it becomes a tangent to this ellipse. So never join to this point because the curve will be on, maybe the curve will go outside that line. So by drawing the generator, make sure that it just touches one of the outermost point of this ellipse. So it should go as a tangent. So I'm drawing a line which just becomes a tangent. And on the other side also, I am drawing that. So the curve inside these two generators should be drawn as a dotted line. So while drawing this, only this part which I have drawn using black lines, that should be darker. And the one in the red lines and red, green and blue, they are all construction lines and should be really light. So they have to be drawn using 2H pencil and this should be drawn as H pencil, drawn with H pencil. So only this cone should be highlighted. So this figure gives the isometric projection of a cone. So for dimension purpose, you can mark this radius or diameter here and the height you can plot here. From here you can draw a horizontal and you can extend this horizontal line and here you can mark the height as or the dimension as 80 mm. And the right top you draw the mark the scale 1:1.